Okay, let's get through 5 and 6 here. So for 5, like we said, it shows the position function of a bicycle. State whether the velocity, right, this column here is positive, negative, or 0 at the different intervals and points, the point D. And for the acceleration, state whether we're speeding up or slowing down. So in order to find out if I'm speeding up or slowing down, I need to look at if the acceleration is positive or negative, right? And take a look at comparing the two, if the signs are the same or the signs are different. So for example, let's just go section by section here, take it easy. So from A to B, right, I'm looking at, let's say my velocity first. So here's time, right? So between 0 seconds and 0.2 seconds, my displacement along the y-axis here is not moving, right? So that means it's in the same position. So that means from section A to B, it's not moving, the bicycle. So if I'm not moving, then I don't have a velocity, then I don't have a speed. So my velocity would be 0. If I don't have a velocity, then I don't have an acceleration, right? Which means I'm not speeding up or slowing down. So that's just NA, or you could just do that and put a line through it. From section B to C, though, we can see that if it's increasing, right, then my velocity is positive. So as time between 0 and 2 and 0.4, my displacement is positive, then my velocity, I just say, is positive by reading that off the graph. But in order to look at my acceleration between points B and C, I need to look at the tangent lines. So here, for the whole acceleration column, unless you're at 0, I need to look at my tangent lines. So I will do my best here. Let's do this in red. So just randomly, if I was picking a spot, for example, here between B and C, and this was my tangent line. So it has a slope, let's say, that looks like that, but I pick a spot farther up along between B and C. Anywhere, let's say here. And I was to draw my tangent line. Hopefully you can see the slope here is less steep, right? And as I move along and get closer to C, my slope of the tangent line is getting more steep. So I'm going from less steep to more steep. So as you move along between the 2 points, if it's getting more steep, then you say that your acceleration is positive. And again, if we go back to the box that's on page 1 there, if the signs are the same for acceleration, if the signs are the same, then it means that you are accelerating. So it says speeding up or slowing down, so we'll say speeding up then, but accelerating, same thing, right? So here I am speeding up as I'm going from B to C. I'm pushing harder on the pedals, the bike is going faster, right? So now let's look at between C and D. Well, again, if I'm looking just that I'm increasing, then my velocity is still positive. I'm still increasing. So I would put positive there. But again, to look at my acceleration, and I need to go back and look at my, my tangent lines. So let's go back to red here. So let's say I pick a spot closer to C. Again, oops. Closer to C, right here. That's very steep if I was to draw a slope tangent line and look at the slope of it. And then if I were to go closer to D, you can see here that we're kind of flattening out, right? That would be my tangent line. So it started out more steep, and as I go along the curve closer to D, I'm getting less steep. So you might want to write that out in that section here, or something like that in there, and also from B to C. So if I'm going from less steep to more steep, again from B to C, then I would put that, if it's getting more steep, then you put positive for acceleration. If here I'm starting out more steep, if I'm going from more steep to less steep, my tangent lines, right, are positive to not as positive, the number would not be as large, then I would say that it's negative. The acceleration is negative. So again, here the signs are different. So if the signs are different, then I'm slowing down. So again, as I'm reaching this peak of D, the bicycle is starting to slow down. slowing down. So what about at point D? At point D again, just if we wanted to go to acceleration, then again, my tangent line would be horizontal, right? So it's neither positive nor negative. So I would just say my acceleration is 0, right? It's a horizontal line. And my velocity, my speed is 0. I'm not moving at that exact point of D, right? So then I'm not speeding up or slowing down again, NA, or you could just put a line through it. Now we're moving to the other side here from D to E. I'm on my way down, then velocity is negative. I'm on my way down, my velocity is negative. My acceleration, again, let's go back and look at, maybe I'll change my color here. My tangent lines. So if I were to pick a spot, let's say right here, and draw a tangent line, and if I were to pick a spot right here and draw a tangent line, it looks like it's starting out less steep. So like, let's say that had a slope of 2, right, from grade 9, and it's going more steep, right? This would have a slope of whatever, 6, a number bigger than 2. So as that's increasing, I'm going from less steep to more steep, right? Then I'm saying that my acceleration is negative. Just changing my color here. So if it's negative, the signs are both the same. So the signs are the same, I'm speeding up. Which makes sense because now I'm going, well, for a bike, I mean, really we're along a horizontal, right? So I'm speeding up in that part. Now, if from E to F, it's still going down. It's not quite, we're not going to quite count that as a flat part yet. We're going to say that it's still decreasing there. So my velocity would be negative. And again, let's look at my tangent lines from E to F. So my tangent lines from E to F, I would start out, again, if I go back to green here, I would start out more steep, right? And then if I get closer to F, it's less steep. So because it's more steep to less steep, it's approaching less steep, right? Then we're gonna say that it's positive. So if it's negative and positive and the signs are different, then I'm slowing down in that section. And you can see here too that you're slowing down. You're getting close to not moving, right? So again, between F and G, my velocity is 0. There's no movement there. I'm not moving. Same here, I'm not moving, right? So acceleration is 0. And again, speeding up or slowing down doesn't exist there, okay? Okay, so let's just get that down or take a screenshot so we can move to 6. Let's clear this. Okay, now 6 is not associated with 5, right? It's a new question. So it's just saying for the positive function, y equals s of t. So here it gives you a graph here, starting out positive. Sketch the graph of the velocity function. So let's say this is our velocity graph. And sketch the graph of our y equals a of t, which is our a acceleration graph. So just looking at the graph above, can I convert that? So if I look at, based on also looking at the bike riding graph up above, this point here is my minimum point, right? And this point here along this displacement function is my maximum point. So at these points, I'm not moving, right? So at these points, I'm going to say my velocity is 0. So if my velocity is 0, then I put it along the line of 0, trying to make a straight line here, and I'm right along the line of my velocity graph. So these 2 points where I'm not moving, my velocity is 0, and I would be along my velocity, right, is 0. Now I take a look at what's happening between, let's go between the 2 points. So between the 2 points here, it's increasing, right? So then my velocity would be increasing. I have a positive velocity. So I would say here my velocity is positive. Between these 2 points, it's increasing, just like the bike riding graph up above. Between this point and to the right, my velocity is decreasing. My velocity is negative. It's going down. So I need to show that somehow. So I have my velocity increasing up to a certain point, and then I have my velocity decreasing, right? And then to continue on with the curve, it would go like this. So in this section of the graph up above, my velocity would be decreasing. So in this section of the graph, my velocity would be less than 0. Then my velocity is positive. Then my velocity is negative again, right? So now comparing my velocity graph to my acceleration graph, again, what happens at the very peak here of my velocity function? My acceleration would be 0 right here. And between this point and this point, my acceleration would be greater than 0. My acceleration would be greater than 0. And then between this point and this point, my acceleration is less than 0, right? So my acceleration is less than 0. So again, if this is where it equals 0 on my acceleration graph, I'm going to be at 0. Acceleration of 0 along this line here. And then I want to say that it's positive to the left of that and negative less than 0 going down to the right of that. So it's going to end up looking something like this, where see acceleration is positive until there is no acceleration, and then the acceleration here is negative. So the acceleration is less than 0. And another way to look at it is this graph here, if we're looking at like derivatives, this original function here looks cubic from grade 11, right? So taking the first derivative of that, this looks quadratic from grade 10. And then taking the derivative of that, or taking the second derivative of the original, now we have something that its derivative, right, the derivative of velocity, or the second derivative of the cubic function, looks linear. So look at how that works. So here again is our displacement function, our original. Sketch the graphs of here's our velocity function, velocity increasing, then velocity decreasing. The places where velocity is 0 is along here, the maximum and minimum points. And then from velocity to acceleration, where our acceleration is 0, and then where acceleration is greater than 0, it's above the graph, and where acceleration is less than 0, we need to be below 0 here on the graph, on the vertical axis.